welcome to today's webinar, Quantifying Water-Sensitive Design for Stormwater Management. In this webinar, we will be demonstrating a workflow that gives you an effective, quantifiable treatment train approach to water-sensitive design. You will see how to apply XP drainage to a site in order to compare pre- and post-development flows and water quality. I'm your presenter today, and for those of you who I haven't met before, my name's Jessica Jeffries and I'm our Products Manager here at XP Solutions. For those of you who are new to XP Solutions, I'll just run through a brief bit of background. XP Solutions has been established for more than 40 years, and over that time we've focused on developing and supporting water modelling software solutions. So we have a lot of experience in hydrology, flood modelling, stormwater design, and various other water resources. Our clients range from small engineering firms to very large professional service companies, and also a lot of regulatory authorities, councils and other agencies. And our software tools focus on combining an easy-to-use graphical interface with strong analytical engines. Our software is very flexible in terms of model building and is very graphical. So you can build, analyse and view results and reports and so on all in one piece of software. So the agenda for today will be an introduction to water sensitive design, followed by a brief look at the proposed Auckland Unitary Plan. Then we'll get into the live software demonstration before answering your questions. We're seeing a change in stormwater management, not just in New Zealand, but all over the world. Stormwater used to be just about assessing the water quantity. So we used to have to show that our flows were restricted into rivers and streams. We then started to consider water quality, and these two remain the main focus of stormwater, but we're now seeing that expand into many more aspects, and in stormwater really offering a multiple benefit approach. We're looking at stormwater management that tries to mimic natural drainage by retaining pollutants on site and treating the water, slowing it down in a similar way to the environment before we, develop and pave these surfaces. So now we also want our stormwater solutions to be attractive and actually contribute to the amenity value of the site. Rather than just being a take on the land, we can actually start to think of these stormwater solutions as adding value. We ideally want the stormwater to contribute to maintaining and even increasing biodiversity. And we also want to encourage water reuse. So this might be via irrigation of urban green spaces or domestic and industrial rainwater harvesting tanks, but these are now becoming part of the stormwater solution rather than something separate. Ideally, we also want stormwater that allows recharge of groundwater and streams and encourages evapotranspiration to improve the air quality and to reduce the urban heat island effect. It's a big challenge, but we're seeing some great examples appearing. This approach to stormwater is referred to in a number of different ways. Water-sensitive design is the term we're seeing in New Zealand, WSD, but this approach shares similarities with approaches used in the UK, such as sustainable drainage systems, referred to as SUDs. In Australia, water-sensitive urban design, referred to as WSUD. And in the United States and many other countries, low-impact development, or LID. We're also seeing the terms green infrastructure and blue-green corridors used. But although there's subtle differences in the definitions, all of these approaches essentially demonstrate a change to the way we value rainwater and a desire to use it to improve our urban environment. And it's really the most significant change to stormwater management in our lifetime. We hope that it will see stormwater design move up the priority list in terms of planning and development, and will help us to improve the quality of our rivers and streams and even the quality of life. So there's an increasing amount of policy surrounding this topic, and each local authority or council is likely to have a different interpretation. But we know that in New Zealand, the Proposed Auckland Unitary Plan and the Auckland Design Manual contain stormwater management guidelines that relate to water-sensitive design. So we'll just take a brief look at a couple of extracts from the Proposed Auckland Unitary Plan. Critical to water-sensitive design is including stormwater management devices in our designs, and the following definition appears in the plan: that a stormwater management device is a device or facility used to reduce stormwater runoff volume, flow and/or contaminant loads prior to discharge. So this tells us what we're expecting from these devices and also gives us some examples. This is a list that it says it includes these devices, and we can see they're mostly what we would describe as green approaches, but not exclusively. There's still obviously a need to combine green approaches with more engineered approaches to stormwater. They are, though, often vegetated, and the vegetation can be a big part of holding back the water and treating the pollutants. And the vegetation is also what contributes to aspects of the stormwater approach in terms of other benefits like amenity and biodiversity and so on. So we've seen those photos there of what they look like in real life. These images demonstrate how we can model some of the stormwater management devices in the software. We need to know the dimensions, and you'll see how we use these images to help us set up our stormwater management devices and indicate exactly which parameters we need. In the next few slides, I'm just going to look at a couple of the descriptions from Part 3 of the Proposed Auckland Unitary Plan, the Regional and District Rules, Section 4.14 on stormwater management. It's worth noting that not all parts of the rules apply to every site, and the site does need to be assessed in accordance with the rest of the rules in terms of the area, land use, percentage impervious and so on. So certainly it's worth getting hold of the document if you may have to comply and getting involved in reading it and so on. I pulled out this extract though on quantity because it tells us that we need to consider the 10% annual exceedance probability and the 1% annual exceedance probability. Or for those of us still working in old money, the 1 in 10-year average recurrence interval and the 1 in 100-year average recurrence interval. So this is an important part of producing a stormwater model. We would have to include these two AEPs in any kind of analysis. Another section relating to quantifying stormwater management is the hydrology mitigation table. Again, I should mention that this is the draft position that has been documented, and we are aware that this may be subject to change prior to adoption, but what it gives us is an indication of what's coming, what we might need to assess, and in particular that we are going to have to quantify our approaches. The final extract I've pulled out there is in section 3.42 of the stormwater management section, tables 3 and 4 on stormwater quality management and stormwater contaminants. And again, the draft situation gives an indication of what is coming and indicates that for some sites we will need to quantify stormwater quality concentrations along with the stormwater quantity, flows, levels and volumes and so on. So we're very excited today to show you our new software program, XP Drainage. We want to show you a workflow that can demonstrate in a quantifiable way an effective treatment train approach to flow and pollution control for stormwater management. XP Drainage can analyse water quality and quantity in stormwater designs that include a range of stormwater management devices, comparing pre and post development scenarios or phases. The software is easy to adapt to meet local guidelines, as it can store away information in templates that you can reuse over and over again. So that will be what we focus on now, talking through that workflow and then showing you the software live. So what we're seeing is that in order to build these treatment trains, these connected stormwater management devices, or stormwater controls as we refer to them in the software, we're typically running through a workflow that is kind of repeatable. So we tend to need to always look at our pre-development site, calculate what's happening there, find out what the runoff is, the volumes, and the pollutant wash-off. Then we want to estimate how much volume do we need for flow control and for pollution control. And then we move on to actually building a mitigation option, building a number of stormwater controls, in some cases, or maybe just one, into a treatment train, connecting those up, locating them on site, and showing how that works. When we come to our results, we normally want to compare our pre and post development flows and pollution removal. And of course, we all know that we're likely to have to modify a design and go back round the loop. So this is the workflow we're going to be working through, we're going to show you today. And the software is really geared up to lead you through this workflow. So just to talk about a couple of things before we go into the software, we'll want to import data into the site, and we think that there's a real opportunity at the beginning of the development to do a quick analysis on our existing site to encourage consideration of the natural flow paths and ponding areas. So we have a simple analysis called Deluge, which allows us to do this and actually demonstrates where those flow paths and ponding areas are. And I'll show you how quick that is to run when we get the software open in a couple of minutes. Then we'll be setting up two phases in our model, a pre and post development phase, but this could also be other mitigation options. It can be more than two phases. We can have any number of phases that we can compare results for. So it's really very, very flexible in terms of what you can use it for. As we build the model, we'll be adding different stormwater management devices, which, as you've already seen, can be graphically represented in the software, and then we'll connect these up to form a treatment train. So I'll switch over to the software now. And to start off with, I want to show you our finish file. So we've got a fairly typical scenario here where if I switch back to our pre-development phase, we had a greenfield location that has been approved for development. We've analysed this pre-development site and surface and chosen suitable stormwater management devices. As I said, we'll call them stormwater controls in the software, and set up a treatment train to deal with water quantity and quality and create a water sensitive design. You can see, if I just give you a quick orientation, on the left hand side we have what we call the tree view. This allows us to see all the objects on the site and interact with them in a similar way to layers work with, for those of you familiar with CAD and GIS software. So we can change our phases here to change what's displayed, look at the stormwater controls we have included, and so on. On the right hand side we have what we refer to as our toolbox, And this is one way of adding objects to our model, dragging and dropping onto the plan. But we have other ways as well, so that you can find the way of working that suits you best. Then along the top we have our main sort of ribbon toolbar, and this is the main tool to help guide you through the workflow. We know you're going to start by bringing in some data, setting up rainfall and pollutants, and then we have some design tools. So once you've got some of that data, actually giving you the ability to do some quick calculations to point us in the right direction. These aren't going to be our final answer, but they're going to help us work out a starting point. Then we'll build our model, move on to analysis and results, and of course we have views and help as well. So this ribbon toolbar is going to be really useful to us. Having set up our model though, we've been able to compare the flows, volumes and pollutant loads between these phases and quantify whether our approach has been suitable. So I'll go to a new blank job and start with setting up our pre-development conditions. So we start on the left here with our site ribbon, and we want to load in some data. So first I'm going to load an image. We can either use the ribbon here or also on the tree view. We can load in data. So I've got a greenfield image here, and if I click OK, that image has a world file with it. It's a JPEG, and so it's loaded in the correct location. We could move that around if we didn't have the world file, and you will have seen there's a number of other image formats that are supported. Next we want to load some surface data, and again I can use the ribbon, or I could have right-clicked on the layer there. So I've got a very simple CSV file. This contains XYZ data, and when I load it in, I simply tell the software which columns relate to which variables, and it will load in that data for me. When I click OK, it actually triangulates the surface and prompts me to save that with a file name, so that I can reuse that surface in other models without having to set it up again. So if I turn on the triangles there, we can see where our site is located, and we can see our surface data there. And if I just turn that off again, you can see this is a greenfield area. Sorry, I've just noticed there's a slight delay for the audience view, so I'll just try and be a little bit more aware of that. We can see that nice greenfield site that we are now going to develop. Loading in the surface data means we can run this simple deluge analysis, but it also means that we can extract data from the surface to set the levels in our drainage systems. So I'll run the deluge just by hitting go. It's water on our site. So if I enter a 15 minutes there, this is taking 50 millimeters of water and analysing it over 15 minutes. I'll just turn off those contours there, and we can see that after that time it just tells us where the water is. So we're not actually looking in specific detail at a certain depth, but what we're doing is we're identifying where our main flow paths are and where our main ponding areas are, and ideally we'd like to see this included as part of the consideration when we're laying out our drainage. So it makes sense if we locate our drainage so that it drains towards the left-hand side of the site and towards this top right-hand corner. We can't always guarantee that will be the case, of course. So once we've done this, we know we're going to need some rainfall, and we're going to need to tell the software which pollutants we want to run. So if we go to rainfall here, there's a number of different design storms, preload methodologies, sort of input into the software. And we also have the option to set up user-defined design storms. If we go to our rainfall manager here, then we can actually load in some rainfall that we've already created. So I'm going to open a tutorial rainfall library, and in here I've set up some rainfall for Auckland based on TP 108. It's pretty easy to set this up. We've set up a temporal pattern which we can see, and then we've put in the multipliers for the intensity there. We'll go through rainfall in more detail in another webinar. I want to move on and show you as much as possible today. So then we move on to pollutants, and in the pollutants layer we open up pollutant data, and we can add whichever pollutants we want to model here. So the software is very flexible in that you can decide what you analyze. So we can input 3 pollutants here, for example. Total suspended solids, phosphorus, nitrogen, for example, but we could add heavy metals and other pollutants if we wanted to. Next, if we turn off this deluge, we want to describe the area for our pre-development site. So we can do this either by drawing it, and that would take us to our build menu, where we could add an inflow area, or we could use the toolbox on the right hand side. But we also have the option under Inflows here to load areas directly from CAD. So if I click on load there and load in a CAD file, I've got the outline of the areas here in the CAD file, and I can just untick these layers if I wanted to, and they wouldn't be loaded, and then click OK, and it brings in those areas for me. Brings them in based on the icon that I have selected under Inflows here, and this is where templates would become really valuable. So I could have pre-prepared an SES area type template and loaded in all those areas with SES already selected. I didn't do that, so what I can do instead is open up these areas and just enter the details. And I can change the runoff method there, and then I've got my standard SES details that I can enter. So for example, putting in the curve numbers and so on. I won't do this for all the areas, but also in the areas there I can enter the pollution data. So this is where I could input how much the concentration of each of these pollutants I'm getting off the site is. And the flexibility of the software means that you do need to obviously refer to local guidelines in order to know what values are suitable to put in there. So I could analyze the pre-development phase on its own, but in this case we want to look at 2 phases, pre-development and post-development. So I'm going to edit this phase, call it pre-development, and then duplicate it so that I have a post-development phase. Now under the post-development phase, which is selected here, I've got a different background image. Instead of the greenfield image, I've got an image that shows the houses on the site. I've also got a CAD file which shows us the layout. And this is useful because if I hadn't imported the areas, I may want to snap to elements in my CAD file, the outlines of each of the areas, for example. These areas I would now want to change so that they reflect impervious areas rather than pervious areas. So I could adjust these and adjust the pollution and so on. I won't spend too long going into that in too much detail today. So then before we actually get started with the rest of the design, going through my workflow up here, I want to have a look at some of the other design tools. So we've got a range of calculators here that help you to get a feel for what you might need in your design for your treatment train. They're not going to be the final answer, but for example, we can get an estimate of the volume of storage for quantity. So if we know we have to meet a certain discharge coefficient, for example, if we have to limit our site to 300 litres per second, and if we know we do have some infiltration on site, we want to see what effect that has. We could also allow for climate change here, an increase in the rainfall. And if we then click on calculate, oh, sorry, forgot to select the rainfall here in my analysis criteria. So because I'm using the design, I've got a validation tool that actually tells me when I've got missing data. So I've selected that, and now if we go back to calculate, it will give an indication of how much storage we need. Now this can be quite a large range, and the reason the range is so large is because we don't know exactly what type of devices we're going to use, but it gives us a starting point. For the water quality tool, this can be useful to, again, give us an indication of the water quality volume, and this typically is used to determine permanent water in ponds or similar. So it might be that you have to have a certain amount of water to deal with the first flush, the high concentration of pollutants, and so you can just enter a simple precipitation depth and calculate that volume. It's not intended to give you the volume that you provide in the stormwater management devices. So that's just an example of some of the design tools there. Then we move on to the build menu, and this is where we really set up the model of treatment train. And the easiest way to do this is to use our add train option. So I'm going to pick a swale and a weir outlet, and at the moment we've got a 4 meter width selected. So if I click on the area here, I can click on where my first swale starts. I can draw that swale, and then that can go into another swale and so on, and I can end that train. And that's a really quick way to set up our designs. Then we would want to go into the details of these devices, and this is where the images really come into play, because this tells us what each of these dimensions above here relate to. So in this case we've actually picked a dry swale which has a trench underneath. So we've got a swale section and a trench section. You can see some of the information is pre-populated, the levels from our surface data. If we have advanced settings like infiltration and retention to take account of the fact that water will be slowed down by the vegetation, that's contained in a separate tab, so you only need to look at it if you want to take account of that. And then we have pollution removal for each section in this stormwater control. You can set these up using two different removal methods. The percentage removal method will just simply remove the percentage you enter. It's not actually affected by the dimensions, but it allows you to show at the end what effect these have in series. And the first order decay method is more complicated. It does take into account the dimensions, but you would need to have a look in more detail at this method. There's extensive description in the help file in order to know what parameters to put in here. So we've got those two options in there for you, but of course you need engineering judgment to put in the right variables. So once we've connected those up and entered the details there, if I just flick back to our finished model, you can see we've got multiple different stormwater devices in there. We could then run the analysis. We selected our rainfall there and actually view the results to see the comparisons between our two models. And there's a number of different results options we can look at. One of the useful ones is the phases report, or one of the most useful, because this allows us to compare our phases. So we can see from our pre-development option we have a maximum inflow of 388 and a total inflow volume of 5,970. In our post-development case, we've exceeded that inflow, the flow and the volume, but we've managed to reduce our outflow volume to lower than the pre-development case. Our outflow volume, there is just a bit higher because we have some permanent water in the system. So this just shows how it will indicate to us what's happening and tell us where we need to look at the design again and rerun the analysis. It also does something similar for the pollution removal, you can see there, and shows us the graphs as well as to what's happening in the model. I'm aware we've gone just a little over the time, so I will flick back to the presentation and just tell you how you can find out more information. We want as many of you as possible to sign up for a free trial. You can email us and we'll send you a link to download the software. And we'll also be running some more webinars, so if you are not already signed up for our mailing list, please do drop us an email and we can go into more detail into some of the aspects of the software. We want your feedback as well, so when you get the software and have a look and install it, tell us what you think and tell us how you think you can use it or what you need in order to do your job. I would like to thank you for joining us today. Thanks again for listening.